Dear students, today's topic is linear momentum. Under linear momentum, we're going to define impulse and also we're going to define momentum. What's momentum? Momentum is the product of the mass and velocity. Before you get a momentum, an object must have its own mass and also the velocity at which it's moving. That's why momentum equals mass times velocity and is also a vector quantity. The unit of momentum is kilogram meter per second. Unit of mass is kilogram. Unit of velocity is meter per second. When you bring the two together, that's kilogram meter per second. When it goes to impulse, the definition of impulse is the product of force and the time taken. That's impulse I equals Ft. The unit of impulse is Newton seconds, because the unit of force is Newton, the unit of time is seconds, that's Newton seconds. Not Newton per second, because it's not division, it's multiplication, Newton seconds. And also is a vector quantity. Let's see a problem to solve. Example 1. A stationary ball is hit by an average force 50 Newton for a time of 0.03 seconds. The first thing to do is to write the parameters. As I always told you, F force equals 50 Newton, time T equals 0.03 seconds. What is the impulse? Formula for impulse, direct formula. Impulse I equals Ft, also 50 times 0.03. Take note, if you are not with your calculator, that's 50 times 3 over decimal is 1. I mean sheet 1, 2, 0, 0. 0 cancels 0, 5 here 1, 5 here 2. Equals 3 over 2. 2 goes in 3, 1. And 1, 0 goes, that's 5. That's Newton seconds. 0.5 Newton seconds. What to do is to write the parameters as usual. Mass is 3.0 kilogram. Velocity is 10 meter per second. We're looking for momentum. The formula for momentum is just mass times velocity. In case you are given in gram, convert it to kilogram by divided by 1000. If you are given standard unit like meter per second, you don't need to leave it at gram. Now, this case you are given 3 kilogram times 10 equals to 30 units. Kilogram for mass, meter per second, 30 kilogram per second. Now, the next thing is Newton's law of motion. Newton's law of motion. Newton's law of motion. The name of the scientist that came about the Newton's law of motion is Sir Isaac Newton, and he came relate force and motion together in the year 1642 to 1727, and he stated the first law of motion as every object continue in a state of rest or of uniform motion in a straight line unless acted upon by an external force. That's what he was trying to say, that every object is going to be at that resting position unless a particular force push it. And also every object will continue to be in motion until it's been acted upon by an external force to stop it. Okay? Now let me say a car is moving. As it's moving, if you don't apply brake, it's going to move. External force is when you put your leg on the brake to apply, or it hits a particular object to stop. It will not stop. That's what he's trying to say. And also second, Newton's law of motion states that the rate of change of momentum is proportional to the impressed force and takes place in direction of that force. The rate of change of momentum. What about the rate of change of momentum? We will say that force, rate of change of momentum, which is mv minus mu. The rate has to have time. Now F now proportional to what's common? M. V minus u over t. V minus u over t is acceleration, F is proportional to ma. When you move constant, F equals to kma. If k equals to 1, what will it turn to? F equals to ma. Is that okay? And the third Newton's law of motion says that to every action there's an equal and opposite reaction. Impulse is equals to change in momentum. When you cross multiply, you have Ft equals m equals to v minus u. Now equals to, when you open the bracket, v minus mu. I is Ft is impulse. Now say I equals to Ft and is equals to mv minus mu. mv stands for final momentum. But we have v as final velocity, final momentum, and mu is referred to as initial momentum. U is referred to as initial momentum. Ft and is equals to change in momentum. Now let's see an example. Balance force of 20 Newton acts on a 4 kilogram mass. Parameters first, please don't forget parameters first. 20 Newton act on a 4 kilogram mass. 4 kilogram. What acceleration? A. What's the relationship that brought the three parameters together, which is F equals to ma. We are looking for A equals F over m. What's our force? 20 divided by 4, which is 5 meters per second squared. Okay, let's bring out the parameters. The mass equals 900 gram. Convert to kilogram because other units are in standard. Divided by 1000, 0.0, 10 goes in 9, 0. Add 0, 10 in 90, 9 kilogram. Determine long determined by horizontal force as F1, 20 Newton. Opposing force, frictional force of 8 Newton. F2 opposes the motion. Now the brake force is F1 minus F2 because it's opposing it, which is 20 minus 8, which is 12 Newton. That's the force. We have to look for acceleration, question mark. Now the formula F equals to ma. Your A now equals F over m. Divide both sides by m. Yeah, what's our force? 12. What's our mass? 0.9. In case you don't have a calculator, you can still solve it. 12 divided by 9 over decimal is 1. Standing for 1. How many figures after decimal? 1. Add a 0. Don't forget this one, they are together. That's 12 over 1 divided by 9 over 10. Change it to multiplication. 12 over 1 times 10 over 9. Turn it upside down. 9 will come down, 10 will go up. Now you are changing it to multiplication. 3 in 3. 3 in 9, 3. 3 in 12, 4. Which is equals to 4 times 10, 40 divided by 3. 3 goes in 4, 1. 3 goes in 10, 3. 3 goes in 3, 3 like that. Solution is 13.33 meters per second squared. A ball of mass m 0.3 kilogram moving with a velocity of 20 meters, that's initial 20 meters per second initial velocity, suddenly hit by a force F is 5 Newton for a time of, that's t, 0.03 seconds. Find its new velocity, they are referring to v. F equals to m into v minus u over t. Take note, we are looking for v. Let's make v the subject of the formula before we start solving. Now, ft equals m v minus u, m into bracket v minus u. ft equals, open bracket, mv, mass times v, mv minus mu. We are looking for v. Let's take this one to the other side. Minus turn to positive plus mu equals to mv. Divide both sides by m. Okay, m cancel m. V equals, let's just separate it, ft over m plus mu over m. M is common to both of them, m cancel m. V equals ft over m plus u. What our f? 5 times time, 0.03 over m, 0.3 plus u, 20, equals 5 times 0.03 divided by 5, 15, 5 times 0, 1, 0. That's 0.15 divided by 0.3 plus 20. Now, not to avoid using calculator, 15 over decimal is 1. I'm going to figure 1 to 2 times 0, 0 over, together, 3 over 10. Decimal is 1. I'm going to figure 1 plus 20. Now, V equals 5 over 15 over 100 divided by 3 over 10 plus 20. Cos 15 in both mass, you have to do division first before both mass. Division before addition. 15 over 100 times 10 over 3. That one is 0, 3 1, 3 5, 5 1, 5 2 plus 20 plus 1 over 2 plus 20 is equals to 1, 2 goes in 1 is 0, 2 goes in 10, 5 plus 20. Now your V equals 20 plus 0.5, 5 is 0, 2. That's 20.5 meter per second. This is the new velocity of motion, final velocity. This is the end of our class. Please subscribe to my channel to get the latest video. Have a nice day.